Okay, welcome to Algebra 2, Section 1.2, Properties of Real Numbers. Today we're going to talk about the classification of numbers. The first thing we need to talk about is your real number system. Real numbers are all numbers. All numbers that you have learned from kindergarten all the way through Algebra 1 will be classified in the real number category. Real numbers can be classified into rational or irrational numbers. Rational numbers are anything that can be written as a fraction. Anything 1/2, 2/3, anything that can be written as a fraction would be a rational number. Irrational numbers are anything, obviously, that's not rational, things that cannot be written as fractions. Examples of irrational numbers: square root of 5, pi, 0.0100100001. Another way to say this is anything that does not terminate, so the fraction does not end, or it's not a repeating fraction. Rational numbers are numbers, again, that we can rewrite as a fraction. 1/2, 1/4, 0, -3, the square root of 4. The square root of 4 can be simplified down as 2, and 2 can be written as a fraction, so therefore 2 would be a rational number. Once it's classified in rational numbers, it can go then to become an integer. Integers are positive and negative whole numbers that include 0. Then you get to go down to your whole numbers. Whole numbers are positive numbers that include 0. And let me scroll this down a little bit for you guys so we can see the rest of the chart. There we go. Natural numbers are positive numbers, whole numbers without 0. And the way that your book represents these, there's a symbol for each one of them. Real numbers are represented by an R. Rational numbers are represented by a Q. Irrational numbers are represented by an I. Integers are represented by a Z, and this is the first time we've encountered a Z in Algebra 2 so far. Anytime I write my Z's, I will put a line through the middle of them just so you guys can definitely tell that that's a Z and not a 2. Whole numbers, we will represent those with a W. And we'll represent naturals with an N. So as you follow the chart here, remember, let's go from the bottom up here. Naturals are positive whole numbers without 0. Whole numbers are positive whole numbers with 0. Integers are your positive and your negative whole numbers, including 0. And rational numbers are any number that can be written as a fraction. Irrational, anything that cannot be written as a fraction. And then your real numbers, all the numbers you've dealt with from kindergarten or before up through Algebra 1. Algebra 2 will get into some imaginary numbers, but we're not quite there yet. So now let's talk about classifying numbers. So let's scroll down here. Let's name the sets that these numbers would be in. And it went away. Hang on just a second. There we go. So -4/3. First of all, is it a fraction? Or is it a real number? That's what we need to decide first. And it is a real number, so we're going to put an R here, for it's a real number. Then the next thing we need to decide, is it a rational or irrational number? Well, if you look at it, it's written as a fraction, so it has to be a rational number. So we're going to put a Q there next. Then we look at our chart. -4/3. Does it simplify down to anything whole number wise? And it doesn't. So it would stop at the rational number. It can't be an integer because it doesn't simplify down to a whole number. So that's where we would stop at -4/3, is just real and rational. So the next one we go to 9/3. Well, 9/3 is a real number. It can be written as a fraction, so it's rational. Then we have to see, does 9/3 simplify down to anything? 9/3, 9 divided by 3, that would simplify to 3. So then, yes, it does. So then we go down here. Well, 3 is an integer because it's a positive whole number. Then we go back. 3 is also in the wholes because it's a positive whole number with 0. So it classifies in the W. And then the last one are just your positive whole numbers, and again, 3's in there. So 3 would work as a natural number as well. So that one is in all of them. Square root of 11. Well, if you type in the square root of 11 on your calculator, you get 3.31662479. So it is a real number, but it can't be written as a fraction. The square root of 11, it doesn't terminate and it doesn't repeat, so it's going to be an irrational number. And once it's an irrational number, we don't have to ask the next question because there's nothing else after irrational. Square root of 25, the square root of 25 is 5, so 5 is a real number. It can be written as a fraction, so it's rational. 5 is an integer as well. It's a whole number, and it's a natural number. Our next one, 0.61 repeating. We get that repeating bar at the top, remember, from middle school that is a repeating bar, so it's a real number. Repeating, so remember back to irrational. Irrational is it doesn't terminate and it doesn't repeat. So this one does repeat, so then that would have to make it a rational number. That means it can be written as a fraction, but it can't go any farther. It can't be an integer because it's not a whole number, it's a fraction. So we're done with that one. 0. 0 is a real number. 0 can be written as a fraction, so it's a rational number. And then if you go back, 0 is in integers and it's in whole numbers, but it's not in the naturals. So we do Z and we do W, and then that would be all of our classifying our numbers. We have classified all of those. So let's go back and let's scroll down to our next thing. We want to talk about, we just want to review some properties real quick. These were definitely done in Algebra 1. You probably did them in 7th grade math, 6th grade math, 5th grade math. You've done these a lot before, so I know a lot of this will be review. Commutative property. Commutative property means if you're adding them, it doesn't matter in which order you add them. So it can be 5 plus 6, like so, or 6 plus 5. Commutative is also for multiplication. You can do A times B, B times A. It doesn't matter, you'll get the same answer. 5 times 6 is going to be the same thing as 6 times 5. The associative property talks about your parentheses. If you're adding three numbers, it doesn't matter where your parentheses are. You're going to get the same answer if you move the parentheses. If you're multiplying three numbers, it also works for multiplication. It doesn't matter where your parentheses are, you're still going to get the same answer. The addition identity, if you add 0 to anything, you're going to get what you had in the beginning. So 6 plus 0 is going to always be 6. A plus 0 is always going to be A. Multiplication identity is 1, which means anything you multiply by 1, you're going to get what you originally had. So 5 times 1 is always going to be 5. A times 1 is always going to be A. The 0 property, anything you multiply by 0 is going to give you 0. The multiplicative inverse. The multiplicative inverse says if I multiply 1/2 by its reciprocal, which means you flip the fraction, by 2 over 1, I should always get 1. So the example over here is 2/3 times 3/2 equals 3 over 2 times 2/3 is equal to 1. Your fraction works that the 3's would cancel each other out and the 2's would cancel each other out, and you're left with 1. The reflexive property says any number is equal to itself, which hopefully by now that you're in Algebra 2, you know that 5 is always going to equal 5, 2 is always going to equal 2. The symmetric property, it says if one number equals another number, then the second number equals the first number. So if A equals B, then B has to equal A, or if you want to see it in numbers, 9 is equal to 6 plus 3. That means 6 plus 3 has to be equal to 9. The transitive property. If A equals B and B equals C, then A and C must equal each other. And we have one more. Let me scroll this down for you. And then we're going to talk about a big property. The substitution property. A number can be substituted for its equal in any expression. And we did substitution property in the last lesson where we said A, B, and C equal these numbers, and you substituted them in and used your order of operations. So you guys are pretty good at that. We need to talk about one more, and then we'll do some examples. Our last property and our biggest property that we talk about is the distributive property. You have to be good at the distributive property to survive Algebra 2. You learned this in Algebra 1. You probably learned this a little bit in 7th grade math. The distributive property is what ties addition and multiplication together. You have to be good at combining like terms to be good at the distributive property. You have to be able to say, well, 5b and 2b, they're like terms because they have the same variable. So I can add them. So 5b plus 2b has to equal 7b. On the second example, 10c minus 1c is equal to 9c. These are like terms, so I can take 10 minus 1 and get 9. So let's talk a little bit more about the distributive property here. On this one in the distributive property, you have to be able to distribute. Distribute means take this a and multiply it by everything inside, because the a is, because of this parenthesis here, it is saying a times everything inside. So the distributive property allows me to multiply the a by everything inside. So a times b is ab, and a times c is ac. Same thing on the second one here, where the a is on the outside of the back. That means you can distribute it this way and get BA plus CA. And same thing with the subtraction one here. So let's do some examples of this. I'm going to scroll this down so we have some more room here. We're going to do 3 examples. I think that's all there is. Yeah, so let's do 3 examples on this. And then we'll be finished. Example number 1. Let's go ahead. If you need to draw your arrows, please. So we have 3 times 2x. Now multiplication, they don't have to be like terms, only addition and subtraction. So 3 times 2x will be 6x plus 3 times y would be 3y. And once I've distributed the 3 through, I can get rid of my parentheses. Plus 5 times 4x. So we have 12x. No, we don't, because 5 times 4 is not 12. Let's change that. See, everybody makes mistakes there. 20x minus 35y. Then you have to combine like terms. So you have 6x and 20x. So you have 26x. And then let's wait to put our sign there because you'll see why in just a second. So we have 3, we'll change colors for this. You have 3y minus 35. So you type in your calculator or do it in your head. 3 minus 35, and you get negative 32y. So then you'd be minus 32y. And that would be your answer there. Now again, I can't combine those because those are not like terms. X and y are not the same, so I can't just add those together. So let's go down to the next one. We'll use this hot pink color. Distribute your 3 to everything, and you'll get to the point where you can do this without using the arrows, but for now, continue to use the arrows until you get really good at it. So we have 3 times 4x. We have 12x. 3 times negative 2y, so minus 6y. Now remember, when you're distributing this 2, it has a negative sign attached to it, so distribute that as well. So you have negative 6x, and you have minus 2y. Go ahead and combine your like terms. So you have 12x minus 6x, so you have 6x. You have negative 6y minus 2y, you have negative 8y. And there's your answer. Okay, the very last one. I would like you guys to solve number 3 on your own, on your notes, and please show me before you move on to the next lesson. Make sure you show me that before you move on to the next lesson, please. Thank you.